So let's put it into. Do you have something that can watch and see what happens if it got the right?
I'll check on my computer.
All right, go ahead and see.
Yeah, so I think thinking a bit more about the issue, I guess one thing that's really interests me is, I've kind of been a bit exposed to crowdsourcing, but I haven't read the literature. And therefore, I guess I haven't thought about it as much. Like I tend to be thinking about other things. But I really like the whole idea of how do we divide up any kind of skill pool into a way that you can actually get people doing it. I mean, you can always think of changing jobs, right? Not just the processes.
Right.
And it's actually quite related to learning at a more advanced level. Because you need people to have particular skills. Or even what are some things that you don't need to train in because it's better to have it outsourced or use digital support in some
Or maybe
way.
they already have the skill.
And you need to support them in doing it. Or do you mean assess it so that you...
Both are true.
Okay.
People say they have skills they don't. I'm sure you know literature that people who actually know it, but downrate their expertise.
Yes.
And people who don't think they're really
Yes.
So sorry, what's the timing?
The timing is that technically it should be 12, but I think it's I think it's going to kind of vary on when Candace or John decide to watch it. So.
Okay.
How long is the talk?
I aimed for 45 minutes.
Okay. I can go and check the big box.
I mean, I just wanted to make sure that I was. Does it tend to be interactive? Do they tend to stop and ask questions in the middle, or does it tend to be more?
Not so often.
Okay, so it's more delivered.
Yes.
Okay.
And when this goes to screencast, I'm just going to chop off all this bit of stuff and stopping and sending bits. But yeah, this is great. Okay, so that's good. Because,
So if I move it.
Which oh, actually, good thing you checked that. Yes. No, it's not actually spine. Let me try that out. The comments is not. Yes. I mean,
What does this guy think? Where's the hangout itself?
Exactly.
It still thinks, okay, no, it sees the right thing.
Yeah. Okay,
Oh, it's
I
just
think
delayed.
it's lagging. Okay. Do I just hit play or you just switch?
Just go back.
Okay, it's good. It's good.
Okay, well, can we get a drink? Go well.
Thanks for coming. Indian food is probably the absolute worst as far as something to eat while you're talking.
It's it will guarantee I speak quickly.
Yeah.
Just put it in a straw and suck it up.
No, it's tasty. If we weigh people down, then they can't escape in the middle.
Right.
So it's
Yeah.
good.
So there's Hey, we're pleased to have Michael Bernstein from my department, the computer science department, talking about some of his research. So I will not spend a lot of time introducing him. I'll just let him go for it, and we will have a good discussion as we go.
Fantastic. Thanks, man. This building was significantly more derelict when I was an undergraduate here. I'm really impressed. All right. So, build social systems. My group's goal is to think about ways to get large groups of people to come together to do things that they might not otherwise be able to do or have the incentives to do. And what I'm going to focus on today is thinking about expertise. And I think expertise is really, in some sense, the end goal of a lot of learning, skill development, and so on. And I want to sort of talk about the entire pipeline from how do we actually empower that kind of expertise and get it there, to what happens once it's there. I'm going to do this in a little bit of a backwards order so I can show you where I want to go and then how I think we can get there. At a high level, what I think is that computation enables us to build these things that I call socio-technical super colliders, to take all the smart people, all of their interests, all their expertise, all their energy, put them at high velocity, quickly rotating chamber, and smash them together into something that's incredible. That allows us to observe things we were never able to observe before, to create things that we could never create before. And what I'm going to try and cover today are three different ways that I think this can happen. One is ways in which we can combine our abilities through the crowd, through the internet, in ways that were possible before. Second is how we can learn from each other. And third is how we can then take and contribute our skills back to the commons so that others can learn from us. So, I don't know how many, actually I'm curious, how many of you have used something like Amazon Mechanical Turk? Right, so it's a micro-task marketplace. People do small tasks for small amounts of money. And the idea is that you have a big thing you got to get done, you split it up into a bunch of small chunks, and then you get a bunch of non-experts, typically sort of amateurs. You train them through a web page and then have them do a bunch of these tasks. And we've seen it being done for text shortening, for image labeling, data collection. Maybe you've run it for some surveys or for some cognitive studies. It's being used all over the place now. But of course, at some point, you want to get towards some complex goal that's not something that you can really snip up. Think of something like software engineering or creating a movie, writing a song. If you cannot create little tiny blocks out of it, it's hard to give it to little tiny people, right? Intuitively. And so I end up being very dissatisfied with this state of the world. And I ask, could we actually crowdsource something more ambitious? Could we take a napkin sketch of something, hand it to the crowd, and guide their process so that they could turn this napkin sketch into a working user-tested prototype in 12 hours? Right? Or could we similarly crowdsource an entire animated video? We have an idea of the kind of thing we want, pull together a team, and at the end of 48 hours, have something that we can actually use and turn around. Think about all the energy that you put into producing these videos for MOOCs already. Or could we actually even put together an entire MOOC platform, right? If we wanted to have the website where things can get uploaded, you could create questions, you could have quizzes, we could put together all of the videos and the content. Again, in about 2 days. Could we do this by capitalizing on the expertise and the energy in the crowd? This is the kind of thing we're trying to do. And the way we're going to do it is actually crowdsource not with these amateurs, but with experts. I'm going to turn away from Mechanical Turk and toward a new class of online marketplaces where experts live. These places are known as Odesk, Elance, although they just merged freelancer, top coder. Maybe you've heard of some of these things. These are people on these platforms. There are people who can sing, act, write, program, whatever you want. And then the interesting challenge becomes, can we use computation to bring these people together and accomplish these really challenging goals in short sprints? And it's not really clear that this would work really well off the top of, if you just try the traditional microtasking environments, because, well, or the microtasking strategies, because crowdsourcing has been optimized for these little tiny, like 1 to 2 minute tasks. Well, maybe you also have some intuition that, if we were to just grab all these people together and let them self-organize, that would work great. Crowdsourcing workflows have these weird setups where maybe we're squeezing out all of the originality and all of the and there's no flexibility, right? It turns out from the management literature, what happens is that actually these self-managed teams, and I'll just read here, are inefficient, riddled with frustrated members, and poorly coordinated. So I think we can do better. And in fact, also from the management literature, and new faculty here in the MS&E department found that teams that just had a lightweight scaffold, and all it did was establish what I would call roles and goals. So who am I relative to the other people, and what are we all trying to do, and how do we get there, is enough to basically significantly outperform by something like 40% teams that were self-managed or previous efforts. So if we can create these sort of lightweight scaffolds, and I'm going to argue that computation can do this, we can really enable these kinds of applications I've been talking about. So I want to combine the management strength of these team scaffolds with the scale and the interactivity of computing. And we're going to do that through something called Flash Teams. So we've been building this framework for basically dynamically assembling groups of experts from the crowd. So I want to say, I want a singer, I want a programmer, and I want an artist. And here's what we're going to have them do together. And we're going to have them follow basically a structured workflow that we can generate on demand to hand off intermediate goals to get something from, say, a low-fidelity sketch all the way out to a high-fidelity prototype that's been user-tested. So we have team members who have certain coordination strategies, and here I'm just drawing lines between any two individuals who might have some sort of dependency or a handoff. We want it to be modular, such that we can replicate it, create more and more and more and more teams, because, well, we have a crowd, we can scale this out. And we want it to be sort of reliable. So if I give you an input, it'll produce an output. So, for example, I give you a napkin sketch, and we give you a mobile application for your local mobile social network or whatever you wanted to create. What's fascinating here is that by doing so, we've injected computation in the middle. And I think that you have similar insights often in online education, that because computation's in the middle, it can modulate the process, which means that these teams can grow and shrink on demand. We can pipeline them so that they're more efficient. We can allow them to combine like Lego blocks, and we can just ask you for what you want and then dynamically create that team on request. And the way we do this, the basic unit is not that surprising. We just call it a block. All it says is, I need some sort of input, like, oh, maybe a low-fidelity mock of what I'm going for. We're going to provide some instructions for how you want to transform that input into an output. So think of it just as sort of like type in, type out. Okay? And all it says is who needs to participate. In this case, we want to give a heuristic evaluation, so we need a UX researcher. Right? And any UX researcher will do, anyone whom we trust. And then we can just chain those blocks, right? So we have the UI designer, maybe a UX researcher, and a developer. And we can pull them together into, over a period of time, a set of these blocks that hand off one to another. So a lo-fi mockup, heuristic evaluation, passing back to a revised mockup, passing to software development, passing to user testing, passing to revised development. That kind of thing. Now, this looks very waterfall style, but you can imagine that we can actually iterate these things until convergence, the sort of D-school standard design thinking workflow. So you can take these things, and just zooming in again, the lo-fi mockup takes this, say, a napkin sketch and produces something in balsamic, some sort of structured low-fidelity thing I would teach in CS 147 Intro to HCI. And then at the end, the heuristic evaluation passes it back. And we can take a number of these things and then just follow your way all the way along the bottom. This is the basic structure that we're going to be building on top of. Is this relatively straightforward, I hope? Great. So if we have that, well, now we can start letting people build them. We're working on a platform called Foundry, where people can actually author these teams. So for example, add the team members that you're looking for. We hook into the Odesk API so that you can just say, oh, this developer, we need web development. These are all categories that come from Odesk, who can do web programming. And there's thousands and thousands of these skills that you can go and ask for on Odesk. And then you can turn around and you can start authoring some of these handoffs. Such that I have the lo-fi prototype, I can create a new event that's going to take a couple hours, that's going to do the heuristic evaluation, and so on. So I'm just taking what I just showed you in a sort of hand-wavy way and instantiating in a piece of software right now. That's all that's happening. So once we do that, this thing can turn around and become a sort of like computational manager, which is fascinating, right? What can start happening is that this thing starts letting people know that this task is running late and sending them emails and coordinating between each other, making sure that this thing actually finished early, so we better start this one early, right? So starting to pull into some of the org stuff that you've seen in a long time ago, but a lot has changed because all of a sudden the crowd is elastic. We can get more people whenever we want, so we can grow. So what does this mean, elasticity, right? We can take something where normally we would require 3 workers, and we can say, nah, actually, by default, let's be optimistic and need 1. And if we actually need it, then sure, let's grow on demand, right? The team can say, we need more developers. Maybe it's because, well, this is just a lot of work, and mythical man notwithstanding, we can just get more people helping. Or let's say that we realize we need someone who has an expertise in database optimization or the Facebook API or something like that. The team can specialize on demand. So we have these general frames that can then be instantiated specifically. We can also pipeline, right? So imagine, now I'm thinking sort of the traditional systems like CS notion of pipelining, where you take something that's incomplete and you start handing it off. So for example, you don't need a complete mock-up in order to start building infrastructure. Right? Once you have a sketch of what you're going for, then you can start setting up the database tables and so on. So all we can do is note when I can take a pipeline input and just compress this thing significantly, about twice as much. And all this can happen automatically without the user needing to worry too much. Modularity is interesting. I guess this is the downside of being near White Plaza. Modularity is interesting because we can now treat these teams in a sense as self-contained. And this is where computing, again, starts to be able to pick this up and do interesting things with it. If it's self-contained, then we can reliably start replicating these things and combining them, right? So we can make 3 of these teams. If we want 3 different MOOC videos, we can make 3 of these teams, just recruit more people. And we can combine them into a large organization. So in fact, when I was suggesting that we could actually build up an entire team that would create a MOOC, this is what that team looked like. We had 3 different implementation teams, animation and education team, and all sorts of things like this. So we're creating these larger scale organizations that really haven't been possible with crowdsourcing with microtasking up before now. And we can also let you create by request. So we have these large library of blocks just because people are creating these tasks. We have everything from like ebooks to these animations, software development that we've tried out. And we have all of these things with structured inputs and outputs. So let's say that you come along and you say, well, I've got a napkin sketch, but I don't want a working user-tested prototype. I want an animation describing my idea, because I'm just trying to convey this to some stakeholders or someone who's not really going to be playing with the prototype. Well, all we really need to do is find the path through all of these blocks that takes me from point A to point B. And this actually turns out to be a problem that artificial intelligence research solved years ago. We can leverage the structured representation. We can translate these things into something known as strips, which is just an action planning language. Like when I open the door, now the door is open. And it can search these things relatively efficiently, just basically by turning this thing into a satisfiability problem. And if you've taken computer science classes, what you would know about a satisfiability problem is that of all of the really hard problems, we've made the most progress on doing this one kind of fast. So in reality, we can solve most of these problems within a couple seconds. So let me show you the kinds of things that we're doing. So here, for these things, again, I'm recruiting off of Odesk. So these are people who self-profess to say, I am an expert at programming, and they've done previous tasks with star ratings, so we know how good they are in theory. And I'm just going to show you a few different outputs. I mentioned these napkin sketches, the animations, these MOOCs, just to give you a taste of what's going on. So here are a bunch of different software prototypes we've created. One thing was trying to do motion tracking. Another one was a local bulletin board, social meetups. These were all, in fact, just napkin sketches of first ideas in minor class. So the kind of thing that students are doing over about 10 weeks, we did in about 20 hours with a flash team. And again, just to get you a little bit more familiar with here, this is one of the find people near me and things we have in common. Now think of this as a high fidelity prototype. This is not something that you would launch and go to Y Combinator today. But the idea that this was able to be instantiated within like a day to something that can be played with and get a sense for whether the design is going to work, I think will surprise me how effective this was able to be. So here's an animation. This is Terry Winograd, who just retired. We wanted to make a story of him building a computer in his garage.
It's the future! It works!
The "it works" was roughly me doing this in the background when the thing actually worked. So this was a team that involved animators, story designers, scripters, directors, and we put together into a Flash team that pipelined various parts of the script back and forth. So we gave them a high-level description of what we wanted. Terry Winograd's retiring. Let's make some celebratory video. And checked in occasionally to make sure they weren't going too far off the beaten path, like make sure Terry Winograd's hair looks sufficiently frizzy. And we got more or less what we were looking for. And I mentioned this sort of composite team. This is, I will admit that we did this before I thought I was going to be speaking at the seminar. What we thought we wanted to try and do was see how well we could combine these modular teams. So what we did is we actually had an education team, where what we did is we had someone who was trained in educational curriculum development come together with someone who's an expert in the domain. So we have these things like singing from the diaphragm, or taking portrait photography, or solving the Towers of Hanoi puzzle. We would combine these topic experts with people who have training in curriculum, and they would work together to develop a script and a set of questions, which they would then hand off to these animation teams that would produce these videos, the kinds of things you see here. And then we had a series of these napkin sketch development teams build the sort of platform along which they could upload the videos, they could put the tests, and so on. So we went in about, what was it, Danielle, like 48 hours? Something like that, from nothing to MOOC. Now these were obviously not full classes, right? These are sort of like long tail offhand things you might want to learn, but you've never had a chance for. But I think you can hopefully extrapolate to what you'd be able to do from there. So that's Flash Teams. I'm going to turn to a different topic here, but if you wanted to stop me and sort of tackle me with interesting questions, this is a good time.
I mean, there are lots of different ways to think about future use of this kind of thing. One thing that occurs to me is, can you use this in a class here?
Mm-hmm.
Provide this as a resource for people to prototype out things that want to do.
Right.
Otherwise, and the dollar numbers are a little bit high for your resource for a large class, and every 3 or 4 people have this, but it's not totally out of the question.
I think.
So I think if you run an e-school class and you design something, have a prototype.
Right.
For this kind of mechanism, that's one.
Yeah, absolutely. I agree that the dollar amounts are a little high for just sort of like someone who doesn't have funding, if that makes sense. So, like at the end of the day, what I want to enable is anyone to either turn around and participate in one of these tasks, or to call on their own crowd to help them with the kinds of things they want to do. And you can imagine building up credit or doing a quid pro quo kind of thing. I don't think we've gotten there yet. The closest we've been thinking about has been more volunteer efforts. We're thinking of collaborating, in fact, at MIT, there's this thing called the Climate CoLab, where they do, there's multiple times a year, these competitions to develop energy efficiency proposals and global climate proposals, and these teams end up being horribly disorganized. So we're thinking of, in this sense, more of a volunteer team. Like in some sense, like the D school already has the variety, right? Every class has to be taught between 2 different departments, and you have like these MBAs, and you have software developers. So I wonder at some scale if what we're doing here is just providing a little bit of scaffolding that would allow for a mixed kind of metaphor. So yeah, all right, we have a developer, but we don't have someone who's a character designer. In my ideal world, what we're able to do is allow you to sort of grow a third arm when you realize that you need some expertise you don't have. And that's, I think, might be marginally on the marginally about as expensive as a textbook. Let me put it that way.
You're right. Do you have any sense what someone participating in one of these things comes to understand about the larger entity that's produced?
So I think the answer is, I think they get it. They don't get it as much as I want them to. So it turns out, so with the team scaffolds literature, again, if you have a joint goal, then it causes more of a team orientation. which is good. I don't think people have a super great team orientation right now. Odesk has this, the way that crowdsourcing with experts right now works is like individual contractors. So you throw out a line, you fish back one, and you sort of work with them. So I have to get over this norm of like, I'm just going to work alone and then hand it off. So what we're starting to do is actually look at ways you might be able to structure handoffs through sort of a pair programming metaphor where I shadow you and then you shadow me, these kinds of things to get that to work better. I don't think we're there yet.
Yeah, that was most of the question was how are people communicating and how are they sharing knowledge between these steps and how much you find embedded trust is a really big issue here that you can just take this out there and you think, oh, okay, I'm going to be static and not add your own risk to it. So I feel like those kinds of things are like I don't see that yet.
So there are I have a couple comments. One is, if your team is truly diverse, which is what I think you want to capitalize on here, is like, okay, you can get 10 software development just like how you do at Microsoft. But if you're truly diverse, it's an interesting question of how you should be collaborating and handing off knowledge in the first place. And I don't profess to have an answer there, but I think that's in a sense what we're trying to solve, right? If you're, think about let's just go in the tech world. Like if you're at Google and you're a designer trying to hand off to engineers or something, you don't just sort of like throw it over the wall and say, take it. There's more of a negotiation, and that's what we're trying to actually get going a little bit more. The idea over time would be that if you participate in multiple of these teams, you start to learn what to expect. That is, I know that the best thing we've done in the example here is just provide examples of the kind of inputs you get, the kind of outputs we're expecting. And that sets the general tone. So if you get something that's way out of the line. The worst case we had was in one of these teams, the team decided to fire someone because the person had just gone way out of bounds. It was interesting that it still worked. Like they found someone new within like a few hours and they kept going. But I think that those scenes are where we're really needing to work on it. Yeah.
I'm not sure small group works. And you have something that's really important with legal. That makes a huge difference. So where does the legal model fit into this?
So there are two possible answers. One, right now, is that it's the end user. So we want to sort of enable the end user to be able to observe, give feedback. The other thing that you might see is something like eventually when you build a house, like you have a head contractor, someone who basically creates and manages the team for you. I have some mixed feelings about this. Like, I wonder how much of the effect of a good leader is the interpersonal skills, which is clearly an important thing, and how much of it is something about just keeping the high-level view, and how much of that can be pulled into software and how much can't be. Clearly, 100% cannot be, but I think we could get somewhere pretty usefully, and then potentially think about having someone who's a really excellent leader, multiplexing their time across multiple teams, right? Because if I can make you more effective, then you need less of your time to sort of handle this.
I guess the other question is teams often have interpersonal problems. We've got an expertise model and a reputation model.
Mm-hmm.
So pick the people. But what about the match?
There are, I'm sure you know there's literature that suggests what kinds of interpersonal get-togethers work and which ones don't. We don't do anything super smart right now. There's a lot of shared grounding just by being early joiners just to this framework. I think that in the ideal world, again, if you have set expectations correctly and you know exactly what your needs are to create and help with, then I think some of that becomes less of an issue, but certainly won't erase completely. So in some sense, I think of this as sort of one end of a tent pole that sort of could go to the other end and say like, oh, everything's not a human, which is how it's sort of traditionally been. I'm saying, how much can competition actually play? And clearly there are going to be trade-offs, right? But hopefully positive externalities. Sure. Can you, services can take many meanings, so I just want to understand what you mean by services.
Like, say if a team, like, the person doesn't necessarily work in a team setting, but they could, and what they're trying to do could be passed off onto someone else that doesn't do what they do. wondering, do you guys see that as another way to implement the system, or is it, specifically the end goal is tangible, creation for products that are.
You're saying you don't need the physical output of the service. Yeah.
So, I mean, in some sense, that would be feasible. That is, if you sort of move your layer of abstraction up a level and say, well, now we're going to actually take on this entire larger part and we don't need to have intermediate stopping points. And in a sense, that's what these sort of end-to-end teams do. Like, you could view them as a black box, right? And there's some process that's become negotiated within some service or team or whatever it would be that. As long as you get to the finish line correctly, that's fine. Our only interaction with this has been an interesting interaction with agglomerates on Odesk, where actually there are some groups where you sort of hire almost a firm, and then they deploy one of their own members, or potentially multiple members for you. We've tended to actually avoid those and just try to get with individuals, just because I think it's a little bit cleaner to follow. But yeah, I mean, certainly you could imagine that if you could create a block that just says, yeah, I'll take a plan and produce a building. That would enable you to do something a little bit more complex. But I mean, again, the more you understand about the internals, the more you can do to sort of modulate it and improve it, that kind of stuff. Yeah?
Just a little bit out of left field.
Good.
But I couldn't stop myself from wondering about how this could be used in a MOOC, not to create the MOOC content, but as a way of where the point was the learning of the people who were parts of the team. So instead of implementing the Desk API,
yes,
the platform would provide a way for the MOOC students to list their skills and what they're working on. And they would implement an endpoint that your tool could use in the same kind of way. And part of what's so important about that is the flexibility of your tool in terms of, well, okay, one person dropped out of the team, on it, and that actually would help with some of the technical problems. It's hard to do teamwork when you have people who drop out.
Right.
Have you thought about that?
I only got as far as thinking about ways that you could pull together people who are learning skills across disparate MOOCs. At which point I immediately realized that ever having tried to do this in person, it's already horrific to try and coordinate schedules and incomplete knowledge. But I would imagine that maybe another way to think about it would be actually capitalize on the diversity that's already there within any single MOOC. Like my student, Michael Carney, and I are thinking about this in the terms of like discussions and talk about, which is another discussion. But I think if you actually capitalize, maybe not on knowledge diversity, e.g. like we have different skills, but maybe geographical diversity or experience diversity.
Right?
Sorry?
Or interest diversity.
Yes.
That some students are interested in one element of the project and some in another.
That's right. I think, and I mean, you get that sort of self-selection in group projects and classes on the ground as well. And I think there's an open question of like, if you codified that, would people self-identify or would they feel comfortable? I don't know, but I think it would be fascinating to try. I agree. All right. I will roll forward. I want to jump all the way from on-demand paid crowds to stuff that's already happened, being able to learn from behavior that's already occurred and embed that into what you're doing now. And a major intuition here, or motivation here, is that the way that people use a system, a design system, is often quite different than the way it was intended. I'm sure if you've ever worked in a building, you've experienced this. If you've ever lived in a city, you've experienced this. And at a large scale, we as designers, broadly speaking, have some intent, but people will muddle through doing what they actually intended to do rather than what we explicitly intended them to do. And let's take programming as one domain. I think many people would notice that people are adapting APIs in ways that they maybe were not intended. That these language idioms are evolving over time. People are changing how they use the language, and that people are repurposing code for new tasks. So this leads to all sorts of questions if you're a programmer, right? Like, what's the best way to do this thing I'm trying to do, right? Does my code follow practice that's been evolving? How is this language actually being used today? So here's an example, right? Here's an idiom in Ruby. Ruby is a web programming language. It's rather magical from my point of view, and it abstracts away a lot of things I'm not even sure how well it compiles. but or was interpreted, excuse me. But you have something like this highlighted thing where hash equals args.last, args.pop. This is something that's not very self-explanatory. It's not really even documented very much on the web. But all it's doing is actually taking an idiom where people tend to pass options to a function as a hash in the last argument. So it says, oh, by the way, if the last thing that you got passed was a hash, grab it and do something with it and hold on to it. Otherwise, just do nothing. And we see these kinds of things all over the place. So we've started seeing if we could identify these things at large scale. We created something called CODEX, which is basically, it's a living corpus of how people program. So we go out to GitHub, find popular projects there, and mine about 3 million lines of these projects into a large database that we then have to normalize. And the idea is that if we do these things, we can create sort of data-driven interfaces. Things that rather than becoming these gigantic rule-based systems where it says, if this, then throw an error, if this, then provide this warning, we could actually say, well, is what you're doing empirically what people tend to do? And we can do things like detecting unwanted code, annotating things that might look funky, like that options hash, and telling you what it's actually doing, and create sort of a utility library that reflects how the language is being used today. And my goal here is to sort of get you to project forward and think about what this also has to do with learning how to program and do web programming in the modern age. Because I think that really people are no longer just stopping at a class. They actually need to do this on-the-ground learning afterwards as well. In order to identify patterns, I just want to give you a sense at a high level of how we do this. We want to say, what would a good programmer do? So we take advantage of the fact that with open source code, in general, code popularity is correlated with code quality. So if the notion is many eyes make alt look shallow, so at least hopefully it's written well. So we index the 100 most popular Ruby projects on GitHub. Then we just need to normalize this all because you have a bunch of text or code, and it's not clear if two things like these two are actually supposed to be the same bit. So we use something called an abstract syntax tree, or an AST, which just is a structured way of representing code. And then we just start squishing things, speaking technically there, to make them the same. So for example, the first thing we might do is rename, say, these identifiers, so that things that say like wist hash or chi hash just become variables. Then we'll take the symbols and normalize them. Then we'll take the strings. And you can see that these things finally collapsed onto basically the same bit. And this tends to be the key with anything you're doing that's data-driven. You want to actually normalize it such that you can identify patterns. And we can start to do things like statistical linting. That is, find things that are unlikely to occur in practice. So here's the IDE that we sort of built this into. If you have ever done Ruby programming, you might or might not recognize the error. What ends up happening here is that it's an unlikely assignment statement. In general, chaining wrong kinds of functions together or assigning from the wrong thing to the wrong thing. Here we're trying to convert a string to lowercase and then assign it to this variable called LC name. Okay? And we're doing it by using a function called downcase bang. And what's going on is that, in fact, downcase bang has a side effect in that it changes this thing in what's called in place. So it changes the variable name and then returns nothing. So LC name ends up being nil or none or null, whatever you would think of, and doesn't do what you intended it to do. And we can notice this because, well, we notice that downcase gets called a bunch of times, and assignments get called a bunch of times, but downcase bang with an assignment is really, really uncommon. So effectively, what you should think of this as saying, like, what you wrote isn't wrong, we're not sure, but it's really weird. And we'd like you to reconsider what's going on here. Likewise, a common error for people who are learning is to take something that might have originally been an array and then start changing all their code, change something into a hash, but not realize that they actually didn't rename this thing. So we have an array called a hash called array, or my int, that's a string. These kinds of things we can capture. All sorts of things. Are we chaining things like splitting and call toString, different kinds of function types, block return values? And like at a high level, all that's really going on here is we're saying, are the components of this thing way more popular than the combination, right? So it's really common to call toString or to call split, but really unusual to call them in combination like this. So we can prevent errors, but we can also help people understand the code that they're reading or writing. So we can identify these common idioms and then annotate them, again, now this time going back out to Odesk. So we can query for these normalized patterns along some dimensions that we might care about, like they're sufficiently popular, they're not too popular, that they're sufficiently complex, and then go out to Odesk, find a Ruby programmer, and say, what is this thing doing? We know that everyone's doing this, but what is it? So, for example, now when you open up your code and you have this thing show up, it's an idiom for creating a nested hash, which is what you can do is sort of have matrix-style lookups in Ruby. So it creates a new hash where like the default value is another hash. But the first time I saw this thing, it's like this is weird, right? Why are they doing this way? Because there's a much more straightforward way to do this. Turns out that much more straightforward way is actually incorrect. So when you look at popular code, you notice that they're doing this instead. Likewise, we can sort of start to capture incantations. I'm sure, especially if you've ever used things like Ruby or R or any of these kinds of things, there's all sorts of incantations that get the magical stuff done that you're looking for. And we can notice that this happens. So for example, this line, all it's doing is actually configuring Rails caching. So we can start to provide human readable labels for large-scale behavior and start to combine them. So if you call standard error.new, it's actually, this is how you raise a custom error. So documentation exists for these things individually, but when you combine them, no such documentation exists. But it turns out a lot of people do. So we can start to get humans to reflect on this and tell us what's going on. So we can finally take these things and use it to generate sort of what I'd call a living library, like a utility package that reflects what people are actually doing, such that you can program using the vernacular rather than sort of the prescriptive linguistics of that language. So, for example, we can take these patterns that we identify and just build them into the language. Turns out a lot of people like to capitalize all the tokens in a string. Okay, so why don't we just actually turn around and give that to people so that they can call that thing directly and not risk getting it wrong. Likewise, this hash.nested thing that I was talking about, which it's really easy to get incorrect, well, we could actually just build that into the language, because it turns out that a lot of people are using this. And what we see is that you actually don't even need that much code to start to notice these patterns. We get around 500,000 lines of code, which is about 1/6 of our entire data set. You start to sort of reach critical mass. And it turns out most of what people are doing here is actually just combining standard library functions. So things that Ruby gives you, people are just having idioms in how they utilize those things. And less commonly we see, here's how to use some crazy external library that I imported in. And sometimes even just doing what's called data control flow, where you just think of this as a complicated if or switch statement, these kinds of things. And it turns out when we ask these experts on Odesk about these snippets, a vast majority of them are considered useful. Most of them can be recomposed into larger blocks. And also most of them have no other form that's more common, which indicates that these things are actually sort of the right way to do things. So I want to actually translate this into a bit more of an education context. So this is a collaboration that my group did with Alex Akin's group, who ran a big compilers MOOC recently, where you can take this same notion and apply it to derivations. So if you were to simply take the idea that people start here and are trying to sort of get down here and solve for x, they take a bunch of individual steps along the way, some of which are incorrect, and people can't get to the end from there, and some of which are actually correct. We can start to notice which paths people tend to take and which ones that they tend to take and then get stuck, and give the user feedback, suggesting, hey, you might want to back up. And all of this is just because we have a structured representation of the process they're following as they're trying to solve the problem. So in the background here is an example of what got deployed on Alex's compilers class. And we're really talking here about sort of any sort of formal domain where the technical term would be derivation, anything like math, science. If you really want to push me on philosophy, we can talk about it. And we've got about 4,000 students using this thing. So the idea would be as a user or a student, you start doing this derivation, and when you get somewhere, it notices that no student who ever got to this point got to the end. This can provide analytics to the instructor and say, hey, instructor, a bunch of people are getting stuck here, who can then leave a hint at that point. It says, actually, you may have multiplied incorrectly. The student can then back up and start following the correct path all the way down. And you can imagine building all sorts of user interface affordances on top of this. I'm not going to go into it here just because I want to make sure we have time for everything else. But I think that I'll stop there. But I think that there's a lot to this notion of taking large-scale behavioral data, which I think many of you have already been thinking about in terms of running studies and learning science, and turning this into user-facing feedback and goals and tools. So I'm thinking a lot about ways in which we can learn from the crowd to improve our own mastery of what we're trying to do. So again, I'll pause here just for a moment before I go on. Complaints, rhymes, soliloquies, anything.
Totally great idea.
Cool. I will take that one. All right. So I want to give you one final thought, which is about non-traditional ways you might think about how we can turn around and put our thoughts back into this greater aggregate. So everything I've been talking about has been a fair amount of work. And in my world with crowdsourcing or any social computing system, and I'm sure you've seen this with MOOCs, I'm probably preaching to the choir here, the more time you require, the less people are going to do it, right? Very simple. Whenever my group is building a social system, we always start with like, what are the lurkers going to do? Will they benefit from this? Then we can talk about, what about the likers? You know, people who be willing to click one button, then the people who then be willing to contribute, and then possibly at the end of the day, moderators, you know, and you lose like an order of magnitude at each step, right? So what we know from the literature on peer production, for example, is that if you have these tasks that are sort of not heterogeneous, e.g. everything's big or everything's small, people can't quite find the right fit for what they're trying to do. And in particular, in my world, I talk about crowdsourcing campaigns. You can think about any social computing enterprise, which I think are one of them. If they can't motivate people to participate, we lose, right? And I know through talking with my student Chinmay all the time that like retention is a big question around MOOCs. I think, again, it's similar here. In fact, if you go to Wikipedia, you see a similar pattern where there's all this aspiration. Everyone wants to contribute to Wikipedia, but they say, oh, I don't have enough time. Or they start and then they drop off. And what we know is that there are all these fantastic psychology studies of things called channel factors, which suggest that a really, really tiny barrier right at the beginning can have huge impacts downstream. So we want to get rid of these tiny barriers by capitalizing on downtime people already have. Self-report, how many people have checked their phone during my talk? Yeah, good. So you are my user group. Excellent. People spend short bursts of time, like cognitive downtime, glancing at their phone all the time. And we want to take advantage of this to mobilize participation in these very, very short bursts of time. We call this twitch crowdsourcing. Like when you can't quite focus, you're sort of twitching down and back. Quick volunteer crowd contributions and via mobile phone. And I want to think about this from the perspective that the unlock screen on your phone is basically a CAPTCHA for your phone. It makes sure you don't butt dial someone. So we're making sure just by swiping that we really intended to unlock the phone. Well, all we really need to do there is replace that with another task that's equally certain that you didn't accidentally do it, and that's equally quick, that might contribute to a goal you care about. And here I'm not talking about pay, although we could. I'm talking about something that you personally want to help the world solve. And we brainstormed a whole host of applications and prototyped a number of these, like mapping human activity in the world, surveying. You can think about micro-tutoring as people, are, for example, are learning English. You could tell them whether the sentence they just wrote is correct or not. Very quick to do. All sorts of things. We focused on a few. Just to give you a sense of the kinds of things that are possible, here's one of them, called census. The idea is that, you know, we can, our world is getting more and more sensed in that physical sensors are doing a better and better job of understanding the static elements in our world, but we don't really understand human activity very well. If you've ever tried a Fitbit, you've probably seen the best of the technology that we have, and you probably know that it's not that great. So our goal was to create this sort of human-centered street view, right? Like where you could look into the computer and see what people do in the world. And simply doing it very quickly. Every time you unlock your phone, we just say, ask you a question like, hey, how many people are there? Very quick, and it unlocks your phone. So here you might say there's a big crowd. In your office, you might say you're alone, and everything in between. And we have a number of these questions, like, what are you up to? Are you working? Are you at home? Are you eating? Are you hanging out? Are you pumping up? This is actually a picture of myself. I'm not sure. How much energy do you have? What are people wearing nearby? Right? When do the suits leave downtown Palo Alto and get replaced by the people in the t-shirts? Right? Like, when does business time end? And how many people are around? And one thing we want to do is give people feedback. So we can say, actually, for your time bucket and your location, here's how many people agreed with your vote. We can deploy this thing, which we did, and you can start to get a sense that we get a full host of data. So on the left is Cambridge, Massachusetts. On the right here is like the broader Bay Area. Up here is San Francisco, down here is San Jose, East Bay, and so on. So you can see these clusters of where the users that we have for this system have labeled what's going on in their world. And in fact, we got users all over the world, including India, Japan, in Africa, North and Europe. So we actually didn't have to go recruit these people too hard. This was one of the nice things. Again, you guys have a user group. Every new system, I have to go recruit new users, but this one was on the easier side. One that we're working on now that got deployed, but we had a default with this human-centered street view. But you could also think about structuring the web. So this one's been implemented as well. Where if you wanted to improve, say, your search engine, there's tons of factual queries. Like, what's the largest state in the US? Google doesn't really know that, actually. But it does know when Stanford was founded. All of this requires something that they call the knowledge graph. It's basically structured data about the world. But if you want structured data, you need verification. Algorithms can do pretty well at starting to guess these facts, but they're really noisy. So we asked, could we take advantage of the algorithms to make guesses and the people to just vet the correct or incorrect responses? And if you've seen Bjorn Hartmann's work at UC Berkeley, you might be familiar with something here that also played a little bit closer to the education space, where they had a vending machine outside of their big lecture hall where people would start to rate whether people had gotten exam questions correct or incorrect, and then when they did enough of these things, they would get vended some candy. They called this basically crowdsourcing to a very targeted crowd of computer science undergraduates who really like candy. So what we do is we take Wikipedia, run it through something called Reverb, which is an information extraction engine, and it makes guesses. We take anything above threshold and we put it in front of the user when they unlock their phone. And they can say yes or no. If it's yes, they're helping us build out this sort of fact tree of, Stanford has 27 ACM fellows, or Stanford has won 104 NCAA championships, these kinds of things. And if they say no, we're sort of just scrolling them through the Wikipedia article that they may have chosen, here in this case Stanford, but you can imagine anything. Like pick your favorite thing, could be Mad Men, whatever, and you'll help us structure that. And you're able to scroll you through the article and tell you how far you are. So the idea would be something like, you say, yes, this is actually correct extraction, and then magical history behind the scenes. Next time someone searched for Stanford Founded, the search engine could tell you directly. A final thought here that we were pursuing is around photo ranking. Simply saying that computer vision and photography, we actually started out by working with product design folks here, need images, right? And there's a lot of systems out there that like stock photo that start to collect them, but they're neither open nor really ranked in a really meaningful way. So we started asking, could people, just by having nice photos on their phone, help us generate a ranked list of really interesting photos for someone who needs them either for a computer vision application or for creative applications? So all you're doing here is you're just simply saying, which of these two you like better? We can tell you how many people agree and go from there. So I'm not going to go too deeply into the evaluation here. I just want to point out that this thing is deployed for Android. So basically, we leave your password alone. If you want to have a passcode on it, you can keep it. We just sort of augment that first swipe unlock. You'll probably notice that it's like on an iPhone, for example, it's 2 swipes. It's a I want to unlock and here's my passcode. So we remove the I want to unlock and my passcode is still there because I do not want to trust my graduate students with implementing a password that is unbreakable. What we find, surprisingly, is that these things are equally quick to do as a slide to unlock. So when we deploy this, we randomly will show someone a slide to unlock screen, a traditional thing, instead of one of these push tasks, and it takes them about the same length of time. In fact, when we do the statistical comparison, only this activity census is slower than slide to unlock. The rest are not statistically distinguishable. Likewise, I don't want to go into the details here, but I'm happy to chat. We did a cognitive load study using something called a 3-back task to get a sense of how much cognitive load we're adding to people's mental abilities here when we insert these twitch tasks. And what we find is that in this case, it's again about the same as a slide to unlock. So we're really not adding significant cognitive load over and beyond what you're typically doing when you sit there and unlock your phone. And in fact, we don't even impact the accuracy of these 3-back tasks. So I'll close with sort of a provocation. which is sort of how I'm viewing the world right now, and I would encourage you to disagree with me. So hopefully I'm convincing you that we can, with computation, create these socio-technical super colliders, or whatever you want to call them, that will help combine human interest and knowledge and activity. That they allow us to guide ourselves as we pull together into groups, that we can learn from each other, that we can contribute our skills back to the common. And reading the tea leaves, for me, I think a lot about these paid crowdsourcing systems. And I ask, what would it take for us to get between where we are right now and a world in which you would feel comfortable if your kids, or say even your students, wanted to become full-time crowd workers? When I read the tea leaves, I see these online markets growing. And when I look at the populations in these MOOCs, I see a lot of them being the same populations of people who are participating or likely participants in crowd work. And I don't think right now we're there. I don't think that if someone were to say, I just graduated from your MOOC, I'm going to go work on Mechanical Turk, you would really endorse that decision. I certainly wouldn't. So this is important, right? So here's the provocation part of this, right? There have been some economists who have estimated the future volume of crowd work, and it's something like, what is that, $454 billion a year, 91 trillion hours, I think, if I'm counting that correctly, and 45 million full-time workers. That's a lot of people who we are collectively training, right, through our activities. And it looks like this. This is Amazon Mechanical Turk. I think this is really not where we want to end up. I think there's a lot of things about exploitative labor going on here, about a lack of flexibility. I just want to close by sort of throwing at you a vision that might be a more productive outcome, right? What is going to be the equivalent of saying, I graduated from Stanford, where I work for Google? What does credentialing look like in an online work world, right? Because these people are going to be coming from your MOOCs and my MOOCs. They're not going to be going to Stanford necessarily, at least very few of them will. And they may not even have stable employment with a single employer. They are jumping around between these different flash teams maybe, or different contractors. What does that mean for how we credential people, right? Because ideally, well, let me show you what it looks like right now. It looks like this. It says, you know, it's basically eBay. 24/7 rapid development, highest quality, exact deadlines, top 3 stars for it. I'm a web rock star, right? I don't think we're there. This scares me, honestly. Like, this means that people do not have what are known as honest signals, where they can convey their skills reliably. We need to build that. And I think that the credentialing that can come out of these sorts of systems that you're working on can really, really help that situation. I still don't think, though, it's not going to look like this. I have 4.2 stars out of 5 as a composer. That seems a little bit weird to me. It misses a lot of the point and the subtlety and what people are good at. But in terms of reputation, I think our goal should be to create these mechanisms that are as straightforward to deploy and interpret as basically saying, I go to Stanford, right? How do we get there between where we are now and where we need to be? And broadly, again, more in education. Here's another provocation. How do we get someone to go from a hello world to becoming an expert, the kind of person who can help me out in these flash teams I was talking about? We need to actually build that entire pipeline, right? Here's what I'm going to claim. I think that crowd work can actually become a part of education. I think that what we can do is take these tasks that are out there that real people need to have done and use them as work study opportunities. Let's say you just learned how to do object-oriented programming, and there's a simple programming task out on this that someone needs help with. We can connect you. Maybe the market can provide you something of a discount in exchange for you giving more mentorship. I think that at the end of the day, don't view graduating from the MOOC as the end goal. I think at the end of the day, we want to connect them with stuff that they're actually going to be doing. And this is something that I'm really, really interested in pursuing. I want to close with a quote from Vannevar Bush. I don't know how many of you have read As We May Think, which was from 1945. This guy was really high up in the military, sort of military research in World War II, was an administrator at MIT. He wrote something called As We May Think, which is, in a sense, launched HCI as a field. People tend to think of it as an extended metaphor for Google Glass. Like he had this sort of glasses and a desk that he could move around. It was sort of the first hypertext concept. But in the middle of it, he has this quote. He says, there's going to be a new profession of trailblazers. And those people really, really enjoy finding useful trails through this web of knowledge. And their inheritance, that is the things that they create, are going to become not only the world record, but the things that their own students build off of. Think of the ways in which the people who are trailblazing today can build the setup for tomorrow. And that's really what I think many of us are trying to do here. And I find this as a very sort of motivating, if 60-year-old at this point, goal that we have not yet accomplished. So this is what I am working toward. I encourage you to do so as well. And I'd be happy to continue discussion. Thanks.
We had good questions during the hour.
Yeah, if you need to run, I will not be upset. Yeah.
You're the one who's think about good stuff. And really, I mean, it's two axes of quadrants, but really saying that the delegation quadrant was a very top role, and then people who did one. And really, only people who are already known to be useful to the class and are motivated and committed, and certain abilities.
Yes.
And so I see that as being experts, but I really want to help see how we can get students to context and that be a motivating career choice. That there's no growth necessarily, but everyone's focused in that class.
Right. My point of view, I've not created this, so now I'm just basically blowing steam. So I need to build the scaffold between them. I think at the beginning, what we need is mentorship and feedback and growth. And it sounds like Carol Dweck will come and talk later about that kind of stuff. And later, when you actually know what you're doing, then perhaps you should be returning the favor and providing that mentorship and leadership. But you can also work much more independently. You could look at people who are, for example, contractors right now, who sort of run their own firms as an example of that. So I think we're making a really strong assumption with the expert crowdsourcing stuff I talked about, that people feel comfortable doing this. And it turns out that right now you have this very self-selecting set of individuals who are on ODesk and are willing and are used to, in fact, working extremely independently. But I think if we want to broaden the reach, which is what I want to do, you're absolutely correct. And like delegation is going to end up feeling isolated as well. So I think we want to avoid something too strong on that account.
We'll take one more question and then we'll just
yeah. Sure. Joseph.
I was wondering, this was really interesting. Do you have any thoughts about what the difference might be between crowdsourcing tasks where people are making contributions to a whole, like everyone does their piece and it goes together, versus crowdsourcing tasks that are about digitally improving? So this is the context I'm thinking about the biggest result education is like I know if I run an experiment, I want to make a math exercise with common people through that. And so I do a version and I send it to someone who's a math teacher, then I send it to someone who's a researcher in X area in Y area, and they just really send feedback. But it's a math exercise is not right. It's more like making these stepwise changes. So I'm just wondering if that's a bit more like the first example of building the app versus the second, and I'm not sure what kind of issues come up.
So in a sense, you're detailing like the historical progression, such that it is in the crowdsourcing field, where if you think about where everything started, it was all about taking a task, treating it in parallel, and then you have some automated way of more less treating it. And when we wanted to start getting more complex and interesting things happening, you had to do these iterative pipelines. And the big challenge there becomes basically, does it evolve into a game of telephone, in which if someone upstream makes a small mistake, you just roll totally off the rails. And so basically the general approach has been to develop these sorts of pipelines or workflows or algorithms, and depending on who you're talking to, the name, that will, within some bounds, sort of more or less do the right thing. But the downside, and if you can solve this, then fantastic, is that it tends to clip off the ends of the distribution. So it gets rid of the really bad stuff, which is what you wanted. But it also gets rid of like people who are really, really creative because they're sort of shoehorned into doing exactly what you asked. And I think that walking that line between sort of independence and control is a really tough one, and perhaps some combination of design human elements and algorithms. But we have this.
All right, great. Thanks again.
Thanks, Coach.
That's great. There's a lot of good topics here, and a lot of good ideas.
Thanks for inviting me.
We have a list of.
Hi, thanks so much. That was wonderful. I'm Pam Sean. I'm at the Graduate School of Education and Learning Design and Technology.
Excellent.
I'm looking at.
Who do you work with there?
So I'm in the master's program, so I don't have someone I work with as if I were at a PhD.
Okay.
But I'm doing it over the course of 2 years. So
Oh,
I'm
cool.
sort of doing a PhD approach to the master's
Yeah,
as much
yeah,
as I can. So my work is at the nexus of education, technology, and childhood trauma.
Okay.
And I'm looking at developing technologies to identify and empower kids living with trauma and to support their teachers in doing the same. So it's a big project, and this kind of crowdsourcing, team building, project management that you're talking about is really exciting to me as a possibility. So I just wanted to ask you a couple things very quickly and then let you go to other people. One is, I unfortunately had a Skype meeting, so it came in late.
Okay.
Would it be possible to get your slides or?
Sure. Actually, Joseph recorded the talk.
Oh, did
He
he?
can give you a
Fantastic.
URL.
Oh, that would be great.
That's the easiest.
And the second is, would it be possible, sort of as I develop the project, to come chat with you?
Yeah, of course.
briefly about it?
The easiest thing is that basically, every week I have office hours, and just
Okay.
drop into any of them.
Great.
And we can always take the conversation from there if there's something interesting. That way you don't have to try and work around my ridiculous
No,
schedule.
that's fantastic.
Just drop in.
Thank you.
Excuse me, the one thing I would point you toward is that there's a student of Rosalind Picard's at the MIT Media Lab.
Yeah.
His name is Rob Morris, who came from, he's been working on crowdsourcing as a means of enabling cognitive reappraisal.
Yeah.
So in a situation where, say, you were depressed or you're worried that you're I failed this test and it's going to ruin the rest of my life, he actually brings in your microtask workers from Mechanical Turks to help you sort of reappraise what's going on and reframe it.
How interesting.
And
That
some
would be
really,
great.
it's some fascinating work. And if you drop me an email, I'd be happy to point you at the paper.
Great.
But he's really interesting because before he went to graduate school, he had a background basically learning to be a psychiatrist.
Right.
So things about not exactly the same issues.
Yeah,
but
no, but it's really interesting.
yeah, much of the training might be similar.
Thank you. That's wonderful. Thanks so much. Good talk. Good to meet you too.
Hi.
Hello, I sent you a map. I'm Judy Kane.
Hi, Judy.
From Australia, Sydney Uni.
Yes.
A couple of things. Two very low-hanging things that maybe you're doing or not. I mean, the heuristic evaluation, the literature says how many experts you need.
3.
And I guess you've got data in here that would say something for this community on how many you need to get whatever it is you need.
Right.
And you've got wonderful data, so I don't know if you're...
That's a great question. We haven't ever tried replicating the number of heuristic evaluators. I mean, if you look at the instance curve, it's sort of 1 gets a lot, and then 2 and 3 get you to, I think it was 80%.
Yeah, of course it also depends on who they are, because the expertise is really important for heuristic evaluation.
That's right. So they have to be trained. I haven't tried doing that. We have done.
If you've got ODESK, perhaps you've got an opportunity.
Yeah, absolutely. I mean, in some sense, what I see here is an opportunity to make systems like ODESK become the experimental platform of the future, where we can just bring in participants from them who have to modulate some elements of how they're collaborating with the team, or how they're negotiating handoffs, or any of these things you were asking before.
Well, also, you were talking about short-term tasks, where I think the team leadership issues are much different from
Potentially.
Actually,
I mean,
most of that literature is about longer term. So.
Right. I mean, that's in a sense that's how we break all of the assumptions, and I don't know what still holds and what doesn't, because many of these teams are intended to live for only 24 to 48 hours, and I think the nature of leadership looks different there.
I'm sure.
But I don't know exactly how or why, because no one really in the management literature has focused on such short time horizons. So we're working with folks in the Management Science and Engineering department who study teams, Melissa Valentine, Pam Hines, all these folks. Daniela, who's sitting out there, who is the graduate student who's leading this Flash Teams work, is actually in MS&E. So it's something we think about a lot, but I don't have answers to yet.
Okay, and the other thing that to mind is you've done this analysis on a really rather modest-sized corpus. Well, you showed that with a rather modest-sized corpus of code, you could find some interesting and potentially useful idioms. I wonder if you thought of doing that in the MOOC study.